This one SQL trick saved me 4 hours of my week. I'm not exaggerating. The query that used to take 20 minutes to write and 10 minutes to debug now takes 30 seconds. And it's not the only one. In the next 6 minutes, I'll show you 10 Postgres-first SQL patterns that separate juniors from seniors. Save this video. You'll come back to it. These aren't theory. These are the queries I write every single day at work. The ones that turn a painful afternoon of debugging into a clean one-liner. 10 patterns, Postgres first, because Postgres is what serious teams ship on. Let's go. Number 1, join types decoded. Most devs default to inner join and pray, but the bug that ate your Friday was probably a missing left join. Inner returns only matching rows. Left keeps every row from the left table, even when the right side is null. Right is the mirror. Full outer keeps both. If you've ever lost users from a report because their orders table was empty, you needed a left join. Pick the join that matches the question, not the one your fingers type by default. Number 2, the group by trap. You write select user order ID, name, count of orders, group by user order ID, and Postgres screams at you. Why? Because every column in your select that isn't aggregated must be in your group by. The fix is to add name to the group by, or wrap it in max or min. Better yet, use a window function and skip the trap entirely. This one error blocks more juniors than any other. Number 3, window functions. This is the line in the sand between junior and senior SQL. Need a running total? A row number per group? The previous row's value? Group by collapses your data. Window functions keep every row and add the calculation alongside. Row number, rank, lag, lead, sum over partition by. Once you learn these, you stop writing self-joins. You stop pulling data into Python to do math. The database does it in one query. Number 4, CTEs. Common table expressions. Nested subqueries are how you write SQL nobody can read 6 months later. CTEs flip that. With active just users as, then with their orders as, then select from those. Top to bottom, like reading a recipe. Postgres also supports recursive CTEs for tree structures, org charts, threaded comments. CTEs are not just nicer syntax. They're how you build queries that survive a code review. Number 5, COALESCE and NULLIF. Null is the silent killer of SQL queries. Sums break, joins drop rows, comparisons return nothing. COALESCE returns the first non-null value from a list, perfect for default values inside a query. NULLIF returns null when 2 values are equal, perfect for avoiding divide by 0 errors. 2 functions used together eliminate 90% of the null chaos in your codebase. Number 6, distinct versus group by versus distinct on. Distinct removes exact duplicates across all selected columns. Group by does the same but lets you aggregate. And then there's Postgres' secret weapon, distinct on, which keeps the first row per group based on the order by. Need the latest order per customer? Distinct on, one line. In other databases, that's a window function plus a subquery. In Postgres, it's free. Number 7, UPSERT with on conflict. You want to insert a row, but if it already exists, update it instead. Without UPSERT, you write a select, then an if, then either an insert or an update. 3 round trips, race conditions everywhere. With Postgres, it's insert into table values. On conflict target, do update set. One atomic statement, no race condition. This pattern alone deletes hundreds of lines of application code. Number 8, update from. Need to update one table based on values from another? Most devs write a correlated subquery and watch their query take forever. Postgres lets you write update table set column equals other dot column from other. Where join condition, it's a join inside an update. Cleaner, faster, and the query planner can actually optimize it. This is how you do bulk updates that finish in seconds instead of minutes. Number 9. Indexes 101. The single biggest reason your queries are slow is missing indexes. Add a B-tree index on any column you filter, join, or order on frequently. For partial data, use a partial index. Index only the rows you actually query. For multiple conditions, a composite index in the right column order. Index the wrong things, and you slow down writes for nothing. Index the right things, and a 10-second query becomes 10 milliseconds. Number 10, explain analyze. This is the senior dev superpower. Put explain analyze in front of any query, and Postgres tells you exactly what it did, which indexes it used, where it did sequential scans, how long each step took. Sequential scan on a million-row table? You're missing an index. Hash, join blowing up memory? Rewrite the query. Stop guessing why your query is slow. Explain analyze tells you every time. 10 patterns. Each one turns a painful query into a clean one. The gap between a junior and a senior SQL developer isn't memorizing syntax. It's knowing which tool fits which problem and reaching for it without thinking. Drop these into your next pull request and watch how much code disappears. If this leveled you up, follow for more dev tips that actually move the needle. Drop a comment with the word SQL if you want a part 2 on query optimization, JSON tricks, and the Postgres features nobody talks about. See you in the next one.